Hello everyone, welcome back. Today I am going to discuss a little sensitive topic, very delicate for me personally because I love HC Verma sir, because whatever subject little that I have is all because of his book, reading that book and solving questions from that book multiple times. I personally believe that his book is the best book in the world. You see all other international books, they undergo so many revisions, 15, 16 times of revision. But our HC Verma sir doesn't care. Hardly any revisions, and yet you see the kind of accuracy you have, almost 100%. Here and there one or two little inconsistencies, but perfectly alright. So his book is definitely the number one book for anybody to read, understand, build conceptual depth there. So very recently, one student, about couple of days back, one student came and said, "Sir, HC Verma sir formula for drift velocity is wrong," she said. And what do you mean? I said, and she said, there is one YouTube channel, in that one lecturer is explaining that HC Verma sir formula is wrong, and in other books it is given like this. So I wanted to go through his video, really hurt, and I wanted to refute him and give him counter argument. That's why I went through his entire video. I didn't understand his logic as such, but I do understand that he was pointing out that HC Verma formula was wrong. I wanted to disprove him. That's why I wanted to study a little bit and analyze it. And this is the basic work out of that. So first of all, for the beginners, drift speed is the average velocity of free electrons inside a conductor when the current is flowing. Whenever you apply electric field from outside, you see that electrons are undergoing collision, the random motion is there, but if you average it out, on an average entire cloud is going with some velocity which is called drift velocity. And to find drift velocity, I just compare it with different books and to understand how various books had given the answers. First, HC Verma sir book, in that he explains that drift velocity, derivations and all, you can go through it later, but just look at the formula there finally. Vd equal to half EE tau by m. So please make a note of that half there. That is the factor you are getting in HC Verma formula. And that's a major controversy here. So just compare it with the Resnick book, Resnick Halliday. I think somehow it got disconnected. Fine. So Resnick and Halliday, there you look at this formula, it is not having that half there, same formula. Just of course here they had mentioned small e and here they had mentioned small q. Both are same only, charge of the electron. But otherwise you see there is only one small variation, that is you don't have half factor in Resnick and Halliday formula. And same way you go for Survey and Jewitt, and there also you don't have that half factor. And I went for multiple books like that. There is C.S. and Zemansky, and there is Young and the other books like that. Everything Friedman is there is one book. All books they were not giving that half factor. And most importantly, this is Feynman lectures, the god of physics. In his book, he has given the formula without that half factor which was there in HC Verma sir formula, and specifically he mentioned that writing that half is wrong. Though the result look very convincing, but there is this little subtle difference, because of that it is not correct. He says specifically that it is wrong. So once Feynman says, then we need to consider definitely. I wanted to really understand what is the problem there. So I went through certain videos given by HC Verma sir about the same question. Somebody asked him, "Sir, why that half factor?" He says very clearly, you see, this applying Newton's laws of motion and kinematic equations, which is classical mechanics basically, to electrons in the solid is grossly inaccurate, because there you need to apply quantum mechanics. So obviously whatever approximation we are doing, they are very grossly approximated one. So 20% to 900% error you may have, meaning 9 times the original value could be the error there. So when you have such errors and then trying to compare two approximate versions, saying that this approximation is better than that approximation, is not very reasonable. That's what his discussion about that was. Yeah, I completely agree with that point, because error is so much. But having said that, this molecular theory or this electron theory, whatever we used calculating this drift velocity, is really powerful, because without much complications, statistics, quantum mechanics, still we are able to get up to that level. Yes, but I agree with HC Verma sir in that point. And later he says one more point in that only, that half factor or 2 factor whatever you are seeing, it is because of the difference in assumptions. So I really wanted to understand what is that assumption specifically which is causing that difference there. So I looked at all the assumptions of the drift velocity formula, comparing both the category of books. One side you have HC Verma book, and you have other side all other standard books, including NCERT textbook. I wanted to understand what are the assumptions implicitly and explicitly there. So these assumptions have seen common. Steady and uniform electric field, both sides is required. Average thermal velocity is taken to be 0, because velocity is vector quantity, they are going in all directions with all possible magnitudes, averaging out to be 0 because of thermal motion. Random and instantaneous collisions impulse is random in magnitude, random in direction, and so the collisions are random, and that too instantaneous, no time duration for collision. That's the assumption we take in both the case, both the category of books. Complete randomization of velocity, this is very interesting, important factor there. So whatever ordered velocity that is being picked up because of the external electric field until the collision, once the collision happens, that is all gone into randomization there. It gets dissipated into random motion, no more ordered motion. Again you have to start all over with the ordered motion with 0 velocity. This is assumption taken in all both the categories, there is no difference there. Long range electrical interactions between electrons and lattice is neglected. In both the cases it is so. And between two successive collisions, the only force that we are going to consider is electric force, which is coming from external field because of the battery applied or external voltage. So these assumptions, if you compare, right, there is no difference there, no difference in between the assumptions. Then why is that factor coming there, that difference? That I could not understand it. I wanted to dive deep little more and to understand why that is coming again further. Then I went to derivation part of it. First I looked at all the derivations of these books, all Resnick and Halliday, and then you have Survey, Jewitt and so on, all other books including NCERT. Precisely this is overall the derivation that goes like this. So what they do is, at one particular instant you take a picture of the electrons, free electrons moving in all directions, 10 power 28 electrons per meter cube, very large number. They are going in all possible directions with different magnitudes. And you take the average of those velocities at that moment, instantaneous average velocity we are calculating, and you will get that is drift velocity. So for example, let us say ith electron I am considering, and that is having two components of velocities. One is the velocity due to random motion, due to collisions, you separate it out, and then there is another velocity component because of ordered motion, because of the external electric field. So that is minus E into capital E bar is the force, electric force, divided by mass will give you acceleration. Acceleration into the time until that last collision, that is Ti, ith electron we are considering. That is the extra velocity that you are picking up because of ordered motion over and above random motion there. So this is the equation we have, and then we do averaging. When you do averaging, then the random velocity averaging will become 0 and the ordered motion alone will survive. In that Ti average, that is going to be what we are going to look at now. So the Ti average is called average time since last collision. Suddenly at this point, this book convert that into relaxation time without giving much explanation, without much understanding and all that. Qualitatively, suddenly they slip that average time since last collision to relaxation time, but relaxation time is different actually. It is the average time between two successive collisions. But we can actually prove that both of them are going to be equal, not same, but they will come out to be equal. But that derivation I am not going to do now, it requires Drude's model and so on. Let us not digress that in that direction, but this is a derivation. This derivation is very simple, very simple compared to HC Verma's derivation. This is simpler, but now let us go to the HC Verma's derivation. What is that he is doing and where is that difference coming? And this is HC Verma's derivation. In that he gives a little bit theory of assumptions, and then straight away he writes this equation without much explanation. Vd, that is drift velocity magnitude, that is equal to half of E by m. E is the force by m is that acceleration into tau square. So if you look at the numerator, it looks like displacement due to that external field, ordered displacement of one electron during tau interval divided by tau, displacement by tau, that is this average velocity you are getting it. It looks reasonable at the outset, but I didn't get that clarity about it, especially after I went through that YouTuber who was claiming that there is a mistake. I wanted to understand a little more by studying it. After studying certain more books, then I got to have certain understanding here. There are two methods of doing average here. One method is at one instant you take all the electrons, large number of electrons, and take the average velocities, and you get average velocity, drift velocity. The other one is you focus on one electron and keep on focusing on it for a long time. Then because of that random collision effect will be averaged out if you give long time. Then you take average displacement totally you calculate divided by total time, you will get the drift velocity. So either you do it for a moment by taking all the electrons, or do it for one electron and taking for a long duration. These are the two assumptions we have here. And what about HCV Sir's derivation here? HCV Sir derivation is, he is taking one electron, and then he is taking average for one electron, and that too for how much duration? Not for long duration, he is doing for only tau duration. You go back and see that formula, you will understand. See, half of E by m into tau square, only for tau duration he is doing, and that too for one electron he is doing it. So that I feel is not a good reasonable assumption. Assumption he has taken okay, but that assumption doesn't look very foolproof or otherwise more commonsensical here. You should have taken longer duration. That is what I felt like. So after thinking little bit, I tried to re-solve this and see how it goes. The HCV problem only, same formula only I wanted to take. I wanted to do the derivation once again. What I do is I take HCV Sir's assumption only, the same idea. I focus on one electron, but instead of focusing for only tau duration, I allow it for a long duration and then try to understand it. In that long duration, let's say n collisions happen. The first collision happened after a t1 time, second collision happened after t2 time, and third collision happened after t3 time. Duration we are talking about. Let's say there are n collisions, which is very large number. Then during that interval, forget about random motion because that average out to 0. The whatever ordered motion you get, that will be added up here. The total displacement due to ordered motion will be equal to half of a into t1 square plus t2 square plus t3 square plus so on tn square, half at square basically, n times added. That is a total displacement, where A equal to electric force upon mass, where electric force is nothing but E into capital E. Okay, we got the displacement. Now the displacement is known to you. I want to find drift velocity. I will write the displacement as drift velocity into total time. So the displacement is replaced with drift velocity into total time here. Total time is how much? T1 plus T2 plus T3 and so on Tn. And that is equal to half of E by m, that is acceleration, into T1 square plus T2 square plus T3 square and so on Tn square. So that is what I have here. Then what I did, I divided both the equations, both sides of the equation by n. And then very easily you see that the left hand side T1 plus T2 plus T3 and so on Tn by n, that is going to be average time duration between two successive collisions, which is relaxation time. Straight away we got relaxation time left hand side. But right hand side you closely observe it, what do you have? T1 square plus T2 square plus T3 square plus so on plus Tn square upon n. This is not average velocity square. In fact, it is RMS velocity square. RMS velocity is what you are supposed to write, RMS time square in fact here. So don't write average time, it is RMS time. So if I replace it with TRMS squared, then the formula will turn out to be Vd equals to half of E by m, that is acceleration, TRMS square by tau, by taking tau this side. This is what I have derived it by taking a larger amount of time, and this is what HCV Sir's derivation. On the right hand side you have it. So compare HCV Sir's derivation formula finally and my formula on the left hand side. Mr. Frame's formula, you can take it. If you compare it, everything is the same except that numerator TRMS square is is there in the place of it, you have tau square for HC Verma Sir formula. I personally feel that by taking RMS value is more reasonable because you have squares on the other side. So if you take TRMS as the value there, denominator is tau only, there is no difference because total time by n only we have taken. If you take that and you calculate TRMS in terms of the mean time, there is a derivation. The derivation I am not going to do now, but this is proved. I have personally checked it 3-4 times. You will get that TRMS equal to root 2 times of mean value, you will get it. The derivation I will do it separately because otherwise the entire idea will be diluted. Now if I substitute that, very interestingly you check it, if I substitute here in my formula whatever I got and simplify it, what do you get here? You see, finally you will get the answer E tau by m, which is what is written in all the standard books. So even if you start with what HC Verma Sir has proposed, instead of taking a small time duration, if you take large time duration and do it, finally you are getting the answer E tau by m only. So I feel that compared to both of them, both are grossly approximations only, still logical point of view, it is better to write E tau by m. And I remember in one book it is written experimentally this particular formula is more closer to the accurate value, experimental value. So with that I will conclude here. This is my take and I hope that you understand. I sincerely believe that somebody will point out a mistake in my logic and thereby HC Verma Sir formula stands strong. But this is what it is. With that I will conclude here. Thank you very much for your time. Bye.